Hello everybody, it's Jamie and we're continuing on our math lessons here. So taking a look now at exponents and numbers and variables and how they interact. When you have an exponent, let's take for example 2 to the second power. When you have that, it's like saying you take the base number right here, which is 2. And this exponent's telling us how many times we're multiplying that number by itself. And in this case, if there's 2, that means that we have 2 2's. And I know that sounds kind of like the little dancing dress, but no, we're saying 2, as in the number 2, of these 2's. If we had 2 to the third power, that'd be like saying, okay, we have 2 times 2 times 2. We have this 3, and it's saying, hey, you're going to multiply the 2 by itself 3 times. And in this case, our answer is going to be 2 times 2 is 4. In this case, 2 times 2 becomes 4, and then times another 2, which ends up giving us an answer of 8. And the key here to remember is that we're really saying here that this is this number being multiplied by itself and not a coefficient, that is something in front of here. The big difference, and this comes across often, I think, in my experiences with tutoring it, the big difference is that when you're working with the exponents, you're multiplying by the base number here. You're not multiplying times the spread that you have up front here. So, for example, if you had 3 times 2, what you're really saying is that you have an addition of 3 2's. It's like saying, I have a set of 3 2's, and I'm going to add them together. 3 times 2 equals 2 plus 2 plus 2, with 2 plus 2 is 4, plus 2 equals 6. Right? Or if you wanted to put it another way, we have 2 times 3. It's like saying we have 2 sets of 3's. We have a 3, and then we have a 3. What's 3 plus 3? 6. That is much different from when we're looking at exponents, where we're really saying we're multiplying these bases. And that could often get confusing once we start bringing in variables. Variables, again, you look typically like x and y. Those are the most commonly used ones, especially in Algebra 1 and Algebra 2. So let's just say you had x to the second power, right? If you remember from our 2 above, well, that'd be like saying that it is x times x. We have the base number, that is, in this case, a variable, times itself. Well, if we had 2 x's, right, we're not saying that we're multiplying them. We're saying, okay, we have an x plus an x. It's a little different. But the nuance there is very important. And I think that's a big source of confusion for students. And it can definitely get rough once you start doing things like multiplying out these variables against each other. So let's take a look real quick at what that can look like. Let's just say you had x to the second power times x to the second power. Well, let's break this down. If we had x to the second power from before, remember again, we have x times x. And again, we have it over here, x times x. What do we have in the middle? We have a multiplication. It's like saying x times x times x times x. Well, if we have 4 x's multiplying by each other, what is that really giving us? That's going to give us now what we understand to be the additive property of multiplying base common variables with their exponents. So in this case, it's really like saying, hey, let's add these 2 together. Why? Well, what we get x to the 4th. And what does that look like based on our knowledge so far? It's like saying we have x times x times x times x. When you see that down below, you're like, hey, that looks just like these guys right here when we broke it apart. And like, yes, that's it. That's exactly it. We have to understand that when we're multiplying these 2 together, we're really adding the exponents, because what we're doing is we're multiplying across. We're multiplying across these base x's. We're not multiplying across these exponents. No, we're not doing that. That's for something separate. That is for when we have an exponent. Let's just say we had x squared. If we took that as a parentheses and multiplied it to a second power, then we can multiply it out. And of course, in this case, it's not as clear because, like, wait, that still gives us x to the fourth because 2 times 2 equals 4. 2 times 2 still gives us 4. But let's do one that has a different multiplier so that we can see a difference. X squared, we're taking that to the third power now. What is that like saying? We're really like saying 2 times 3, and that's going to give us x to the sixth. And we know from looking at this progression right here, x to the sixth is not the same. That is not the same at all when we look at the amount of times you multiply the x. You get x, 1, 2, 3, 4, 5, 6. That's multiplied by 6 times x, times x, times x, times x. I'm going to get a breath by the end of this, times x, right? 1, 2, 3, 4, 5, and 6. Big difference, and that has to be noted. Let's take it to the next level. Let's take it to the next level here, and we're going to add the coefficients. Remember, coefficient means that we have something in front of the x. We have some sort of number. And in this case, we could say it's 2, right? Let's just say we had 2x squared, and we took it now to times 2x squared. Okay, well, we know from above that we're going to get x to the fourth, but what about these guys? What happens when we multiply these? Well, it's multiplying those two by each other. So 2 times 2 equals 4. Now we have 4x squared times x to the second power. Of course, square root of second power gives us 4x to the fourth. And you're like, okay, all right, I could kind of see where this is going, but what happens when we change up, start making things, weird? What if they don't have the same, variable that's, up here? Okay, well, let's take a look. Maybe we'll do 2x to the third times 3x to the second power. Well, let's take it to the principles that we have so far. If we have the same base here, the same x, okay, that means that we can go ahead and we can add those guys. If we have now these coefficients, we can multiply them out. So it becomes 2 times 3, right? What does that give us? It gives us 6x to the fifth power. What's 2 plus 3 is 5. It's like saying, okay, we have 6 sets of the x to the fifth power. It's like as if we went down here, we said, okay, just look at the 6 part. It's like say we had x to the fifth plus 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 x to the fifth. Ready up, breath. 1, 2, 3, 4, 5, and plus x to the fifth. So a lot of math could be broken down and poured out of this, and that's why we have these kinds of notations, because we want to make it easier for people to read and work with. But the key is that you don't get confused. You don't get confused on those elements. What happens when you multiply the variables with the common base? And that means you're going to be adding those exponents. And then you can multiply the coefficients, the numbers in front. But all that said, don't lose sight the second that they add something in. So for example, if we had x squared, y to the third, don't lose sight of what we just did. Now we're going to multiply it times x squared. We have this x times the x over here, but we also have this y. Well, remember, we have to work with the same bases, so don't get lost. Don't get lost when they add something in. Remember, you're looking for the same bases. That's going to give us x to the fourth, y to the third. Don't get lost. Make sure you're watching your base elements, because those are the things we have to work with. Now, where it gets one little bit trickier is when we're doing addition or subtraction of the exponents. And so when we're looking at, let's just say we had x squared plus x squared. Well, we can work with this. Why? Because these are the same, right? If these two are the same, then it's like we have 2x squared. Why? Because we have 2 of them. What's 1 plus 1? There's, technically a 1 here in front of it, multiplying. What's 1 plus 1 equals 2. But if we had x to the third plus x squared, we can't put those together because of the differences. And you're saying, well, wait, what? We could multiply them out before. Yes, we could multiply them out before, but that's because the cumulative effect of multiplying works when these additive properties don't. Here's an example why. Imagine that this was a -1, right? Well, -1 to the third power ends up being -1. -1 over here to the second power becomes a 1. And if you didn't know that from previous lessons, it's because when you have a negative times a negative, it equals a positive. So we have 3 sets of these -1s. That's what it breaks down to. It's like saying -1. If we say x equals -1, it's like say we have 3 of these -1s, right? And we have 2 of them here. Okay, well, this becomes -1 plus 1, and that gives us 0. However, if we were to add these together, right, let's just say we get x to the third plus x squared, and we just were like, oh, well, we could just add them together like we add together the exponents. So you got x to the fifth. Well, guess what? Since this is odd, that's like saying we have -1, to the fifth, and now with 5 -1s, it's going to end up being our answer of -1, right? So this cannot be. No, do not do that. It changes the nature of the equation. So these are introductory concepts that have to be fleshed through and practiced on quite a bit. And a bit of the playing with it comes from plugging in numbers and seeing how they relate to each other. So go ahead, start playing around with it. Use the variables, then go ahead and put in something for it. If you have a negative number, try saying, okay, -1 equals x, or say something positive, 1 equals x, and start playing around with it so you can figure it out and see how they relate.